In this series of videos, we're using the openFrameworks C++ Creator Coding Toolkit, an XBox Kinect sensor, and we're going to build ourselves a 3D photo booth. Welcome back. In this video, we're continuing looking at the XBox Kinect 3D sensor, and this applies to the Xbox One and also to the Xbox 2. We've got from a previous video our Xbox Kinect sensor. I'm just going to pop that over there. And we ran through some basic code. We've set up an openFrameworks project. We've included the Kinect Xbox header. We've got the library abilities now. We make a Kinect object in openFrameworks using the OFX-Kinect add-on. In our CPP file, we set up the registration, we initialize the Kinect, and we opened a connection to it. And in our update function, we call Kinect update to grab new data from it. We added a key pressed function using a switch statement. If the switch detects a P key, we change this Boolean value from false to true and true to false as a toggle. And we either call our function that we made last time, draw point cloud, or we just ask the Kinect for the RGB data or the depth data and draw them to screen. So telling this to build, it looks a little like this. So we have our RGB and we have our depth image. We can see those on screen, and when I press the P key, I get this point cloud that I've generated by polling through all of the X and Y matrices and pulling out the Z values for our depth image. Now, what we're going to do is we're going to go and improve that a little bit. And the first thing that I want is to be able to have a look around. So in my header file, I'm going to use the openFrameworks EZCam, which is a great little utility that we can add in very simply to give us controls that we can drag and look around in 3D. So I'm just going to call that cam and tell it to initialize. And in my draw routine, if I'm drawing a point cloud, I'm going to say cam begin, ask it to draw all the 3D stuff, and then cam end. That should now give me a 3D camera that I can have a look around my point cloud. So let's run that and see what we've got. So here we go. We have our debug images. I press the P key, and there's my point cloud. It's upside down, and if I have a look, it's kind of back to front, but I can see there is my point cloud, and with the EZCam add-on, I can look around and see all of the 3D information. And if I zoom in, you can see how the whole image is made just from dots, from these individual vertices in the mesh that we're drawing. So the first thing that I'm going to do is I'm going to fix this being upside down and the wrong way around. So I'm going to come to my draw point cloud routine, and I'm going to push matrix, which freezes everything, do some translations, draw my point cloud, and then unfreeze it. So if I'm drawing something somewhere else, it's not going to mess with that. The first thing that I'm going to do is I'm going to say OF scale, And then I can scale in 3 dimensions. I'm going to scale 1, -1, -1, which should turn it upside down and backwards. -1, -1, -1. And then I've got this translation, which moves the position back 1,000 pixels in the Z direction. So let's have a quick look and see whether we've got that right. Hit the P key, that's much better. And if I zoom out slightly, you can see there's a 3D sensor. And on the wall behind me in my studio here, you can see the shadow from the infrared sensor. So if I line this up sort of exactly, as the beam from the infrared sensor diverges, you get a shadow behind the object. So it's not making a 3D all the way around model. It's just showing me the front surfaces of things. If I move out of the way a little bit, you can see the far wall of the studio. With my chair and my coffee machine and racks of old electronics and all of that kind of stuff. So this is great. I'm getting exactly what I want coming out, but I'm going to do one more thing. So I'm going to quit this, and in my draw routine, I'm not just going to get the XYZ information from get world coordinate. I'm going to say point cloud dot add color. Now, this implicitly adds a color at the current vertex. So when I add a vertex or a point into my point cloud mesh that I'm generating inside this X and Y loop, I'm going to say Kinect dot get color at, in exactly the same way that I can say get the XYZ position at a world coordinate, I'm going to say get the color at X and Y and add that. So I'm going to add a vertex and it's going to have a color attached to that vertex point. So I'm building a mesh that has color on the surface. So now if I draw vertices, hey presto, you can see each of the dots in my point cloud image is colored by the RGB information that we're bringing back from the depth sensor. You can see on the other side of the studio there's some work that I've got in preparation, and we're actually getting relatively good resolution. And if I zoom out using my EZCam, you can see all of the studio, the whole object, me, etc. Very, very simple. Now, what I can also do is I can draw in a variety of different ways. And one of the options of a mesh is the mode. So I'm going to set the mode to be, and the keyword should come up here, OF, and here we go. We can make it lines and points and patches and triangles and so on. And there's quite a lot of information that you start getting into about how 3D objects are drawn. We don't have any lines, we don't have any triangulation joining the points up to make surfaces. So we're just drawing the points, and I want to say just draw the primitive points. And what I can do is I can specify how big those points are going to be when we draw a point cloud. So down here I'm going to say GL point size, and then I say how big I want these dots that my point cloud is being made up of to be drawn. And I'm going to say I want them to be 3 pixels. And I'm going to show you an interesting thing that is important to remember when you're doing 3D work in openFrameworks. So we're going to set this to draw again. It's going to draw all of our dots at 3 pixels. And you can see they're a little larger, so it seems thicker. And when I zoom in, the points overlap slightly. Now, if I scroll, you'll see an interesting thing. My head's disappearing behind the background, even though it's spatially in the right place. And this is because openFrameworks is drawing things in the order that it appears to the software, to the program, rather than the order in which they appear depth-wise. So I need openFrameworks to set that up, and the simplest thing that I can do is to say OF enable a thing called depth test. So it has a look and says, what order should these be drawn in 3D? And I'm going to say OF disable depth test at the end. And now when I draw, objects in the background will be overwritten by objects in the foreground. And if we go and have a look at our GL point size and set this to be bigger quite a bit, it's going to draw us nice big fat blobs for our point cloud, which may be what you want depending upon what your use for this is. So I press P, and now you can see I'm getting these big, fat, 10 pixel blobs for drawing my point cloud. And I can make them bigger and bigger and bigger and get a range of different effects depending upon what it is that I want to do. So we have our nice beautiful blobby point cloud there. There's one more thing that I want to do, which is actually I want to false color what I've got. And I can use the routine that we're adding here, add color, and instead of saying point cloud add color, get it from the real world or from the Kinect world, I want to set the color up to go in different saturations or different hues, sorry, from close to far. And I'm going to use HSB, which is a hue, saturation, and luminance value. I could use RGB if I wanted, but HSB is easier because I can keep the saturation and the brightness the same and just change a hue. So I can go through a color palette, but keeping all the colors similar, whereas with RGB it becomes a little bit more complicated because of how the color space is made. I'm also going to be doing a video about that. But I'm going to say point cloud dot add color, and I want to I think I'm going to make a color first, and it'll be easier. OF set OF color dot color, and then I'm going to color dot set as HSB, so that's hue, saturation, and brightness, 3 different values. And depending upon different models, you'll use different amounts, so do check the documentation at openFrameworks.cc. Here I want to use 255, 255, 255 as the maximum values. I'm only going to change the hue. That's the base color, but I want the saturation to be 255, so super saturated colors, and also I want it to be 255 maximum brightness, so each of these colors will be fully saturated and bright, and then I'm only going to change the hue. what I'm going to do is I'm going to use the Z value that I'm getting from get world coordinate at to control the saturation. So I'm going to make a point.z. In a moment I'm going to make a point value, and I'm going to say that the Z value of the point will be my saturation, but I need to map that, so I'm going to use OF map. And map allows me to say, here's an input value, and it can be between this and this, and I want you to translate that or map it to be between that and that. So I'm going to bring in a value that's going to be between, actually it's going to be between the front threshold and the back threshold, but let's say between 0 and 8,000 millimeters, 8 meters, which is what the Kinect values can generally be. So I'm going to say get the Z value is my input value. The starting is going to be 100. The ending is going to be 8,000. And then map that to between 0 and 255. So that's going to give me a range that my saturation could be between 0 and 255. And then I'm going to get the, that this is the hue. And it's going to set the saturation and then the brightness. Now, I've said use point. Point doesn't exist yet, but what I'm going to do is I'm going to grab the Kinect world coordinate and grab the Z value out of that. So I'm going to make an OF vector 3 object and call it point. And then I'm going to say point is going to be the XYZ values from Kinect world coordinate, and then I'm going to just use that to say add vertex based upon the XYZs in the point. And then I'm going to pull just the Z value to use that in this map statement to be the hue color that I want. And then here, point cloud add color, this color that I've used. So I'm making a vector 3 point XYZ. I'm adding the values from get Kinect world coordinates, and then I'm using that to add a vertex into my point cloud. I make a color, and I map the color to be HSB rather than RGB. So it has 3 components: the hue, the saturation, and the brightness. The saturation and the brightness I'm keeping constant. And then the hue, I'm grabbing the Z value that we get from Kinect world coordinate and mapping it to be between 100 and 8,000 to output 0 to 255. So it'll give us a hue value between 0 and 255. And then I'm adding that to be the color of that point in my mesh. So let's run it and see if it works. So I have my RGB and my depth image debug, and there it is. If I press the P key, I've got my huge blobby head, and as you can see, objects that are close, objects that are far away, and I've colored my whole space based upon the HSB values, hue, saturation, and brightness, rather than the RGB values. To make this a little clearer, I'm just going to come to the GL point size that we used earlier, set that a bit smaller, and have another look. So here's my debug. Hit P, and there depth separated point cloud in HSB. So that's it for this video. In the next video, I'll be looking at setting some controls and how we can use thresholding to change the foreground and the background and separate out only sections of the data that we have in our point cloud. So if you've liked this video, please subscribe to the channel and like, and leave a comment below telling us what you'd like to see and any feedback, improvements, any thoughts, and also the kind of stuff that we can help you out with in coding for artists.